So have you heard about Mojo-V? It's this new RISC-V extension that focuses on privacy-oriented programming. Pretty fascinating.
Wait, seriously, privacy-oriented. That sounds like a game changer. How does it actually work?
It implements secret computation by encrypting memory and using dedicated secret registers. No more relying solely on software trust.
That's intriguing. So, does it mean sensitive data stays completely hidden during computation?
Exactly, it's designed to be blind and silent, preventing any direct disclosures or side-channel leaks.
That's a bold claim, but isn't there a catch? I mean, how does it perform in real-world applications?
Great question. Early results show it's nearly as fast as native execution, with a performance boost of several orders compared to homomorphic encryption.
Wow, that sounds impressive. But can it handle all types of computations efficiently?
It's primarily focused on integer and floating point computations for now, but more capabilities are planned for future releases.
What about integration? How does Mojo-V fit within the existing RISC-V architecture?
It integrates seamlessly with just a mode bit and 4 new instructions, which is actually quite minimal.
That's interesting, but does that mean it can be easily adopted by developers?
Yes, the simplicity of integration is a key advantage. Developers can incorporate it without massive changes to their systems.
But doesn't that also mean it might be limited in its scope? I mean, what about more complex applications?
True, there are limits. The current focus is on secret integer and floating point computations, but future releases will expand functionality.
I'm curious about the security side. How are they ensuring the computations remain secure?
They use a fixed symmetric key cipher for now, but plans for public key infrastructure support are on the roadmap.
That makes sense, but is a fixed key secure enough for sensitive applications?
Good point, fixed keys can be risky, but the encryption protocol aims to mitigate some of those risks.
I see, so it's a balance of performance and security. What's next for Mojo-V?
Future releases will include LLVM compiler support and benchmarks to test performance under various scenarios.
That's promising. What benchmarks are they using to evaluate performance?
They have hand-coded examples like bubble sort and a security test suite that covers various scenarios.
Sounds thorough, but isn't there a risk in relying on hand-coded tests?
Absolutely, hand-coded tests can introduce biases. The real challenge will be scaling those benchmarks effectively.
That's a valid concern. Benchmarking can be tricky, especially when looking for generalizable results.
Right, and it's also about ensuring that they cover edge cases to avoid potential vulnerabilities.
Speaking of vulnerabilities, how do they plan to handle future security threats?
They have a roadmap for additional features, but adapting to new threats in real time is always a challenge.
So, there's a lot riding on the adaptability of Mojo-V's design.
Exactly, it has to evolve with the landscape of computational threats while maintaining performance.
That's quite a balancing act. What implications do you think this has for developers?
It opens doors for creating secure applications without compromising performance, which is huge.
But do you think it will be universally adopted? There are so many competing technologies out there.
That's a good question. Adoption depends on how well they market its benefits and support the developer community.
Plus, the learning curve. Developers need to be trained on how to leverage these new features effectively.
Totally, and there's always the risk of fragmentation if not enough developers jump on board.
Exactly. But if they can prove the efficiency and security, I think it could catch on.
For sure, but then there's the question of whether the benefits outweigh the transition costs.
Right? So many factors at play. It'll be interesting to see how this unfolds.
Absolutely, with the rise in data breaches, solutions like Mojo-V could be more critical than ever.
It really makes you think about how we approach data security in the future.
Definitely so many layers to consider, it's a complex yet fascinating landscape.
And it feels like we're just scratching the surface of what's possible with secure computation.
Right? I can't wait to see how developers start to implement Mojo-V in their systems.
Same here, I think we should keep an eye on this development. It's bound to evolve.
Agreed, the future of secure computing is exciting and full of potential.
And who knows, This might pave the way for even more innovative solutions in the tech world.
Exactly, it opens up so many possibilities for privacy and security in our digital lives.
So what are we waiting for? Let's dive deeper into these developments together.
Absolutely, there's a lot to explore and it promises to be an enlightening journey.